I'm going to discuss my solution to this LeetCode problem, complement of base 10 integer. This problem is today's challenge in October LeetCoding challenge. I am Channa Bankapur. I'm a trainer at Go Master Technologies, and this video is being made for the YouTube channel of Go Master Technologies. Please do subscribe to it. This is an easy problem. So here we have an integer n, which is a non-negative integer, and consider the binary representation of that. So they have explained an example where 5 is the integer, so the binary representation of that is 101. So when you complement this 101, you're going to get 010, and whose value is 2. So that's essentially what we need to do. Given n, we need to get the complement of that, right? So notice there are no leading zeros of n. So that means 101 should not be written as 0101, even though technically this is also 5. If you take complement of this one, it's going to look like 1010, which is actually 10. So this is not what we're expecting. We're expecting 2, right? Because there are no leading zeros, right? Except for n equal to 0. In that case, there is only 1 0, so it has to be a leading 0, right? So this is the question. It's not really hard. So suppose, let me take a little more elaborate example. Suppose if it is the input n is 11010, right? The value of this one is, I think, 26, right? So now what is the answer to this? What is the complement of this? It's going to be 00101. So the answer should be 5. But how do we get that? It looks like it's easy. For every bit, we just have to see whether it is 0 or 1, and then complement that, right? Or toggle that bit, right? So that's what we need to do. But we need to stop at the most significant one of your integer n. We should not go to the next bit, right? So that's where we need to stop, and that's the only little difficulty here. So to do that, what I'm going to do is I'm going to keep right shifting n, so that after 5 right shifts, this most significant bit will also go out of range and it becomes 0, right? So I'm going to set some I equal to 0, and so I indicates the number of times we need to kind of left shift in the resulting number, so that we get that integer. So the result is going to be initialized to say zeros, all zeros, right? So we don't know how many bits are there. Obviously, we're going to take an int, so this is okay. And we take the first bit. So how do we get the first bit? Least significant bit can always be obtained by n and 1, something like this, right? So if I bitwise and with just 1, every other bit is going to be masked out. So only that least significant bit is going to be visible, which is 0 in this case. If it is 0, we need 1 here. So we need to put 1 here, right? So at the moment I equal to 0, that means we are not going to left shift anywhere. So that's okay. We got this one. Now when I go to the next one, so when I right shift it, n becomes now from 11010 to 1101. So now when I look at the last least significant bit, it is 1. I should not be doing anything. I should just ignore it and then right shift again. It becomes 110, right? Now there is a 0 here. We can figure that out by this one. And because of that, we need to basically put 1 in this place. But how do I know this is the place I need to set it to 1, right? This is the place. So I must have increased or incremented I twice, so I must have been 2. So what I'm going to do is I'm going to just left shift 1 by I number of times. That way I'm going to get some masks which look like 00100. Now if I just or this uh, with this bit, so what it's going to have is with the result, what's going to happen is we're going to set this to 1, right? So essentially what happens is result like bitwise or with 1 left shifted I number of times is going to basically set this bit. So this is an operation to set a particular bit, ith bit from least significant bit, right? So we can keep doing it until n becomes 0. So n in another 2 iterations, n is going to become 0, and that's when we're going to stop, right? So it's not much, it's not very hard in that sense. Let me quickly code that. I can code that live. So we need a result. So result I'm going to initialize to 0, right? And also we need that counter I, so that we need to know how many left shifts I do to basically set that bit, ith bit we need to set in the result, right? So as long as n is not 0, I keep doing this. N is greater than 0, right? So what should I do? I'm going to figure out that whether that bit, least significant bit of n is 1 or 0. We are interested in 0 actually. So if I take n and bitwise and with 1, I'm going to get that last bit. If that bit is 0, we need to set ith bit in the result. So how do I get ith bit? So result is going to be result bitwise or with one left shifted I number of times, right? So this is a constant time operation. Actually, it doesn't look like that, but it is. So and then what else we need to do? So if we increment it, and then after that, anyway, whether it is last bit is 0 or 1, we are going to right shift this n by 1, right? So that way it is going to reduce, right? So also we need to increase I along with that. So I also going to be incremented like this, right? So finally, when I come out of that, n is going to be 0, and then that result is going to be updated that way, all right? So I just have to return result now, all right? So this should work. Let's just run for the sample test case whether it works. So for 5 it is 2, it is correct, and we had our own test case which was 26. Let's see if it works for that. So for 26, the expected and my answer both are 5, so that is correct. Let me submit it and it should look good. So we have a wrong answer here. So that means it failed for one of the test cases. When input is 0, I'm outputting as 0, but expected is 1. So I think they have a special case for 0 because I'm not really considering any leading zeros here. When n is 0, the output is also 0, but they are expecting it to be 1. It is more of a special case that doesn't fit into this logic. So I'm going to separate it out. If n equal to 0, I'm going to just return 1, right? And hopefully there are no other special cases like that, right? So let me submit it, and yeah, it is accepted, right? So it's not a complicated problem, so it doesn't take significant amount of time. I don't think as in pretty much everyone's solution is going to be just 0 milliseconds. So yeah, this is the fastest way in a way to do it. All right. So if you know any other way of doing this one, or if you have any comments on my solution, if you have questions, please do comment below. All right. Happy coding. Thanks for watching.